In this video, we're going to go over an introduction of exponents and radicals. But before we get to exponents and radicals, I want to start by doing a quick overview of operators. Now, you know what operators are. You've worked with them. You just maybe haven't called them operators before. Operators are the things we do in math. In other words, there are verbs. So, for example, addition is an operator. So, subtraction is operator. Addition is the most basic operator, and subtraction is its opposite. Now, if we go up a step on that, we would have multiplication, because multiplication is repeated addition, and its opposite is division. Then up one more step is when we get to exponents and radicals. So I'm going to represent exponents with an E and radicals with an R. So the reason why this is a step up is because exponents are repeated multiplication. Let me give you an example so you can see what I mean. Let's say we have 2 plus 2 plus 2 plus 2. So anytime we're adding things over and over again like that, we kind of develop a shorthand for it in math. So here, this is repeating addition, so really what we're doing is adding 2 4 times, or we're taking 2 times 4. So in that way, multiplication is just adding the same number over and over again. Exponents work the same way, except they're representing repeated multiplication. So let's say instead of adding, I take 2 times 2 times 2 times 2. So now I'm multiplying 2 4 times. Well, I can represent that as 2 to the 4. So because of that, the way multiplication and addition relate is very similar to the way exponents and multiplication relate, because they're just one step up in this process of repeating the same operation over and over again. I'm going to talk a lot about operators, and in particular this structure where they build on each other, because all of math that we're going to be covering is governed by the structure of these operators. Not just that addition adds things together, but the fact that multiplication is repeated addition elicits the properties that we'll be talking about. So we'll visit this over and over again throughout the course. But for now, let's clear this out and look specifically at exponents. Okay, here we have 2 to the 4th, which again is 2 times 2 times 2 times 2. Okay, now what I want to emphasize here is 2 is what we call the base, and the 4 is the exponent. Sometimes that's also called the power. Exponent and power in math are interchangeable words. So the base is what we're multiplying, and the exponent tells us how many times we're multiplying it. That's just language I'm going to use over and over again, so it's important to know what the different objects are called that we're referring to in math. Now let's look at an example. In this example, our directions are to evaluate. I will always, as we cover these different examples, I'll explain to you what the directions means. It's important to learn the language of the directions, because that's what on your test will tell you what to do. So here, evaluate, when we say evaluate in math, it means to find a value. Your answer will be a number. It won't involve variables. When it still involves variables, oftentimes we'll use the word simplify, but we're not there yet. We're going to evaluate, so we're just going to take the expression we're given and grind it down to the one number it represents. So first, let's look at 3 times 2 to the 3rd, and this is just to remind you what order we're going to tackle this in, because math is not done left to right. It's done based on operators. So first, what we're going to do is evaluate the exponent, and then we'll do the multiplication. So first we will do the 2 to the 3rd, and then we'll take the result of that number and multiply it times 3. So 2 to the 3rd is 2 times 2 times 2, which equals 8, so that gives us 3 times 8, which equals 24. Let's contrast that to part B. Now what I've done is taken the 3 times 2 and wrapped it in parentheses and then raised it to the third. Now this is telling us to do the multiplication of 3 and 2 first. Without those parentheses, you would always do the exponents first. But on this one, what we have is 6 to the third. And now we'll evaluate the exponents. So 6 to the third is a good example of when you should just, it would be okay to go to your calculator if you need to do that. 6 squared is 36, and then we would need to multiply that by another 6. That gives us 216. So again, it's okay if you punch that into your calculator to get it, but I do want you to understand that 6 to the third means multiplying 6 times itself 3 times. It's that structure that will help you once they become variables, because you won't be able to punch variables into your calculator. So you need to understand what's happening and not just be able to get the numeric result on your calculator. Let's look at a slightly different example now. Alright, so now what our directions are still evaluate, so we want to find the value for these expressions. And what I'm going to do here is I'm going to start by just telling you what the results are, and then we'll talk about why I'm getting that. So the first one here is going to be 9, and the second one is going to be a negative 9. So they're not the same. Whether there are parentheses there or not makes a difference. And so that's what I want to talk about. So we're getting the 9 because 3 times 3 is 9. The question is what's going on with the negative sign? So the first one there is the easiest one to accept. It tends to be the one that does what you expect it to do. So when we have these parentheses here, what that's saying is take everything that's in the parentheses as one number and repeat it 2 times. That's what our exponent's telling us to do. So this is saying what we need to do is take a negative 3 times a negative 3. Well, a negative times a negative is a positive, and since 3 times 3 is 9, we get a positive 9. So that's why it's coming out to be a positive 9, and that's what most people want it to be. So that's not the problem. The real problem is with this second guy. It gets pretty weird. In the second guy without the parentheses, what it is telling us is that only the 3 will be the base. So only the 3 will we square. So in other words, this is like saying negative 3 times 3. It's like the negative is something other than part of the number 3. The way this is expressed. And that's really weird and hard to accept, but it is how the notation works. And so then with only one negative, that's why we end up with the negative 9. This is actually similar to something we saw in the previous example. In the previous example, we looked at 3 times 2 to the third, and I said we had to do the 2 to the third part first, and then we could multiply by 3. Well, it's kind of the same thing happening here, where our negative sign is just a number in of itself. And so we could think of that as negative 1 times our 3 squared, where that negative sign is a separate negative 1 that has to be multiplied after we do the squaring. So that's how you need to look at it when there's not any parentheses wrapped around the number. Now what I want to do is look at a part C that's similar, just to emphasize what is going on here. Alright, so here we have the negative 3 squared inside of parentheses, but if you look, the parentheses placement is different in part C than they are in part A. So in part C, this is actually going to work out to be a negative 9. Part C and part B are the same, not part A and part C. And so this is important to realize the placement of the parentheses, because your calculator knows this rule, and you can use your calculator to help you out on it, but if you don't enter the parentheses correctly, it's not going to help you too well. So what's happening there is if we look just inside the parentheses, and ignore the fact that the parentheses are there, that expression is the exact same thing as the expression in B. Okay? And so since inside the parentheses it's the same as what we have in B, then what that's going to give us is the result we got in B inside of parentheses. Now, there's nothing going on outside of the parentheses, so there's nothing else to compute, to deal with regarding the parentheses. So they're not going to change the effect of the expression, so then it just simplifies down to a -9. So it makes a big difference. It's not just parentheses that cause this, it's the placement of the parentheses as well. Let's look at one more example just to make sure we're tracking with what's happening here. Alright, so example 3, evaluate. Here we have kind of the same idea being looked at, just different numbers involved. So the first one does not have parentheses. So what that means, as we saw in the previous example, is that the negative sign does not get repeated given by the exponent. So we're just going to repeat the 2 without repeating the negative sign. 2 times 2 times 2 is 8, so that's going to give us a -8 as our result. Okay, so the second guy does have parentheses and the exponent's outside of those parentheses, so we're going to repeat everything that's inside the parentheses the number of times that the exponent tells us. So we have -2 times itself 3 times, and then -2 times -2 is a +4, times another -2 is a -8. So here we actually get the same results, but for different reasons, and that's where it's the reasons that matter. So this is a good example of how it's not about what the answer is so much as how you got it. It's the reasons that matter, and that's going to continue to build that will affect what we learn and build on with this concept of exponents. So go ahead and practice some problems with exponents, and then we will dive into what's going on with radicals a little bit.